Hey guys, I want to go ahead and go over some of these differential equations, FRQs. Now this one's from 2015. And what's interesting is in 2015, they had the differential FRQ. In 2016, they did. But ever since 2016, it's been an interesting pattern. So in 2016, they had it. 2017, they didn't have it. 2018, they did have an FRQ for differential equations. In 2019, last year, they didn't have it. So we can't be dogmatic about it, but something tells me it might be in this year's FRQ. And they're already set. The questions are already prepared. They're already set to go. But we're trying to figure out which ones would be it. So I'm thinking, just a hunch, you might get something like a differential equation. And since we're only getting two this year, it's important we kind of try to focus on those. So just an FYI, so let's go ahead and do this one. This one's from 2015, just to give you different variations of it. It says, write the equation of the line tangent to the curve. As soon as I see this, write the equation of the line tangent, I start off with my equation, y minus y1 equals m times x minus x1. Okay, plug in your points right here with negative 1 and 1. So if y is 1, you get y minus 1. M, I don't know, x, when x is negative 1 here, boom, becomes a plus 1. Okay, all I need to do is figure out that m. Well, that slope comes from right here. Here's what they give you. So they give us, it says, consider the curve given by the equation. It can be shown that this is the derivative of this curve. So we're going to go ahead and plug in negative 1, 1 here to get our slope. So we're going to get dy dx. Okay, 1. On the bottom we have 3 times 1 squared minus negative 1. Okay, and now be careful. I know it's timed and you kind of feel rushed sometimes, but just kind of talk yourself through it, because if you mess up, you got to go back and fix it. So you want to do it, you don't want to work too slow, but you want to work quickly, efficiently, but not recklessly. So 1 squared is 1 times 3 is 3, and then this becomes a plus 1, so 3 plus 1. So that becomes 1/4. And so this is the equation. Boom, you're done. Don't change it, don't fix it, don't simplify, just leave it like this. Okay, they'll give you full credit. If you mess up for some reason, let's say you try to put it in slope intercept form and then you mess up, you put, instead of putting a positive one, you put a negative one, the whole thing's wrong. Okay, so just be careful. Just be careful of that. So part A is done. And when you think about it, guys, part A is usually the easiest part. So that kind of gives the hint. You know what? This part should be pretty easy. And remember, if you get 50%, 60%, you're talking about getting a 4 or a 5 on the question on the test. Each one is worth 9 points. So if you get half, let's say you get 4 out of 9, 5 out of 9, you're on your way to getting a 4 or 5. So that's good. So, and back in, let me see, back in 2015, this question was 2 points. You get the slope and you get this, that's 2 points. Great. Next one says, find the coordinates of all the points on the curve at which the line tangent to the curve at the point is vertical. So let's try to dissect what's important here. Find the coordinate points. The tangent line is what? Vertical. Well, when is a tangent line vertical? A vertical tangent line, right, is like this. What's the slope of a tangent line? Well, the slope of a vertical line is undefined. Well, when is it undefined? When the denominator is 0. Remember, from algebra 1, let's say you have 4 divided by 0. You can't, right? That would be undefined. So I'm going to set this guy in the bottom equal to 0. Okay, 3y squared minus x equal to 0. Okay, well, that doesn't help me much, but that means that x is equal to positive 3y squared. Now, what am I trying to find out? I'm trying to find the coordinates of all points on the curve. On the what? On the curve. So now I'm going to use this guy right here, okay, and plug in this value here to figure out my x and my y. So I have y cubed minus x. Okay, what's my x value? I'm just going to write it here. xy equals to 2. So we already know our x. So x is 3y squared, and then we have another y there is equal to 2. So when we solve it, we get y cubed minus 3y cubed is equal to 2. we do, whoops, sorry about that. We do some math there. We get negative 2y cubed is equal to 2y cubed is equal to negative 1. Let's do it up here to give me space. The cube root of negative 1 is negative 1. Boom, we got it. So now we have y equals negative 1, okay? Y equals negative 1 right there. Now I can figure out my x. How do I figure out my x? Just plug it in here. So x is going to equal to 3 times negative 1 squared, and that should give you 3. So the point that it would give you a vertical tangent for this guy is at 3 comma 1. Okay guys, 3 comma 1. All right, and you want to put that, okay, 3 comma 1 is the point which gives us a vertical tangent. Okay, and there it is, guys. 3 negative 1. Whoops. So not too bad, not too difficult. You just got to be able to see it. Okay. So this part is worth 3 points. If you only got to this part here, you at least get 1 point. Okay. So that's very, very doable. Part C. Okay. So now we got to evaluate the second one. The second derivative dy dx. Okay. At the point on the curve where x equals negative 1 and y equals 1. So what do I have to do? I got to take the derivative of this guy right here. Okay. So this is going to be the quotient rule. Remember the quotient rule if you don't know it. Low d high minus high d low. So the low is 3y squared. D high, the derivative of the high, the derivative of y. Okay, the derivative of y is 1. But because it's with respect to y, it's going to be dy dx. Low d high minus high times the derivative of the low. The derivative, sorry guys, I got to keep moving. The derivative of this guy is 6y. Okay. It's going to be 6y times dy dx. Okay. Minus 1. Okay. Because it's with respect to the derivative of that x, okay? All over the square of what's below, okay? Wow, it's a lot of work, huh? A lot of stuff in there. So now what we want to do, because they want the slope at what point? They want the slope at negative 1, 1. So we're going to go ahead and plug that in, okay? All right. So they want the second derivative at negative 1 comma 1. All right, so let's go ahead and do this. This is going to be 1. Now be careful here, okay, because you're going to see these double negatives pop up. Okay, don't go too mental math on yourself, okay? Just be careful with that. What's dy dx? Remember, we figured it out. Dy dx in the first part is 1/4. And what you'll notice is you're going to need a, b, and parts of A and B to figure out part C. Okay, so just keep that in mind. What about y? So y is 1. 6 times 1, I'll just put 6 because I know that. And then dy dx is 1/4 again. Okay, minus 1. Okay, on the bottom, so we have 3 times y squared, 1 squared, minus that negative 1, and all that squared. Okay, so now here's where we can go ahead and start simplifying it out and doing some mental math, okay? So just be careful. So that's going to give me 3 plus 1, so that's 4. 4 times 1/4, okay, minus, and I see I'm going very carefully here. And then 6 times 1 is 6 times 1/4, so that'd be 6/4. So minus 1, and then 6/4 minus 1, all over. What about the bottom? Okay, 1 squared is 1, 3, 3 plus 1 is 4 squared. Okay, then over here we just keep simplifying. 4 times 1 is 4, divided by 4 is 1, minus, and then we have 6/4 minus 4/4 all over 4 squared. Okay? And then 6/4 minus 4/4, that's 2/4. Okay? Or that's 1/2 over 16. Okay? So 1 whole minus 1/2, well, that's 1/2 over 16. Okay? Now, to be honest with you, I don't know to what extent you can leave it. I would say you can leave it like this because you don't want to make a mistake in the algebra, and then this would be perfectly acceptable because it is right, but it's not simplified. Now, your college professor, of course, is going to want it simplified, but for the AP exam, you can go ahead and leave it like this. Okay. Just be careful on your algebra. Okay. But let's go ahead and finish it here. Multiply the top and the bottom by 2. You're going to get 1 over 32. And that's your slope when x equals -1 and y equals 1. All right. I want to go ahead and do other ones from other years here. This is a good one. This is from also 2015. Actually, it's question number 4. I don't know if this was... Yeah, it's also FRQ, but it had no calculator in it. All right. So you're probably going to give you some set of points to graph. Okay. Sketch the slope field, and this is pretty easy. Okay. Let me see how many points they gave just for the graph here. Kind of interesting. Just always good to know. So just 2 points. Just if you just get the graph correct, they're going to give you 2 points right off the bat, and that's good. So all you got to do is figure out the slope. So here, this is 0, 1. So when x is 0, y is 1. X is 0, y is 1. So that means 0 minus 1, that's a -1. There you go. What about 0, 2? When x is 0, y is 2. Well, -2. Even steeper. Okay. What about -1? 0, -1. X is 0, y is -1. That means it's a +1. Okay. And then over here, 1, -1. When x is 1, y is -1. So when x is 1, y is -1. So be careful, okay? You're going to have that double negative. And I wouldn't be surprised if they kind of throw in that guy in there with that double negative, okay? So then that becomes 2 plus 1, and that becomes a 3. All right? Very steep. And then we go over here, 1, 1. So 1, 1. So be careful. 2 times 1 is 2 minus 1. So that means that's a positive slope of 1. And then the last one is 1, 2. That means it would be 2 minus 2, which would be 0. So you have a horizontal. And if you do all of that, guys, you're going to get a 2, which is great. Let's do letter B. It says, find the second derivative in terms of x and y. Determine the concavity, that's important, of all the solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Okay. Now, I want you guys to think about this. Okay, I got to take the second derivative, okay? What does the second derivative tell me? Concavity. Okay. The first derivative is the slope, but the second derivative tells me concavity. So keep that in the back of your mind, okay? So let's go ahead and take the second derivative of this one. So part B, we have dy dx is 2x minus y. So I got to take the second derivative of that guy. So the second derivative, okay, the derivative of 2x will just be 2, okay, minus the derivative of y is 1, okay, but because it's with respect to y, we got to do dy over dx. So that's my derivative. Now be careful because you're not done. What's my dy dx? My dy dx from the original problem, remember, is 2x minus y. So what you're going to have to do is you're going to have to plug that guy in here. So essentially, okay, second derivative is equal to 2 minus 2x minus y, which means it's going to be 2 minus 2x plus y. Okay, and that's it. And that's all she wrote. You're done. So if you get the first 2 questions right, that's 4 points out of 9. So you're well on your way to getting at least a 3, if not a 4. Okay. Okay, so very important. Okay, guys. So let's go ahead and do letter C. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 2 equals 3. Does f have a relative minimum, relative maximum? That's important. Or neither at x equals 2. Interesting. Okay. Those are key words. Remember, how do we find the minimum or the maximum? Okay. Remember your steps when you started learning this? Well, what do? You take the first derivative. You set it what? You set it equal to 0. That's your, and to find your what? You find your critical points, right? And then what do? You do a number line, right? Remember that? Right, so first derivative, set it equal to 0 to find your critical point. So that's the first thing we have to do, because they want to find, does f have a relative minimum or a maximum at x equals 2? Okay, so what do we have to do? All right, what's my derivative? Hey, they gave it to me, didn't they? Okay, they gave it to me. So I want to see, okay, if this is a critical point. I want to see if this is a critical point. So I got to see, at what point at x equals 2. Okay, and actually they give me this point here, 2 comma 3. Okay, so my derivative is dy dx is equal to 2x minus y. So I gotta set the derivative equal to 0. Okay, so let me see here, 2x minus y has to be equal to 0 in order for it to be a critical point. What's the point that they give me? The initial condition, 2 comma 3. So they want me to find out at this point, okay, is there a max or is there a minimum? Okay, so plug in the 2. See, 2 minus 3. Okay, 4 minus 3. Well, that's 1. Wait a minute. That's not 0. There's no way of telling. Because, see, in order for it to get a critical point, you have to set the derivative equal to 0. So there's no way of telling. There's no way of telling if there's a maximum or a minimum. Okay? So you would say, I'm not going to write it out, but say, therefore, f has neither a relative max or a minimum at x equals 2. Okay, hopefully that makes sense, guys. And then hopefully I have enough space here. I don't know if I will. So for part D. Part D, it says, find the values of the constant m and b for which this guy is a solution to the differential equation. So wait a minute. This guy is a solution to the differential equation. Okay. That means when I plug this guy into the differential equation, that means it would make it true. That's what it means. Okay. Remember when we did, for example, like y prime, minus 2 double y prime is equal to 3, right? And then you had to verify the solution, right? Then you would plug it in here, and see if it gives you 3. That's essentially what we're doing. Okay. And so what we have to do, guys, okay, let me erase this real quick, is we have to figure out if that's a solution. Okay, so how do we figure out if this guy is a solution to the differential equation? Well, we're going to go ahead and take the derivative. So we have y equals mx plus b. Okay, and essentially all we got to do is take the derivative of this guy. So let's see, dy dx. The derivative of mx, remember m is a constant, so it's like if it's 3x, that means it's m. Okay. Now, we go ahead and continue from here. Okay. Now, what's dy dx? Yeah, you guessed it. 2x minus y. So now, you get 2x minus y is equal to m. Okay, that doesn't really help me out much, right? But because we got to solve for something, right? Well, I want like terms. Well, guess what? Look at what is y equal to. Y equals is mx plus b. Okay, so now we have this guy. So 2x minus y is equal to mx, plus b is equal to m. So then I got to solve that. So let's go ahead and distribute that one. So that's going to give me 2x minus mx minus b is equal to m. Bring the m to the other side. So 2x minus mx minus b minus m is equal to nothing. Well, how do I solve this? Well, what can I factor out? I can factor out here an x. So that's going to give me 2 minus m. Factor out negative 1. So that gives me b plus m. Okay. And then from here, well, 2 minus m, I can set that equal to 0. And then that means m is equal to 2. And then for this guy, we're going to have b plus m is equal to 0. That means b is equal to negative m. That means b is going to equal to negative 2. And there it is. Those are your values that would give you in order for this guy to be a particular solution, okay, to the differential equation. M would have to be 2, b equals negative 2. Now, it makes sense D was probably the most difficult, the longest, okay, but you see how we had to kind of dissect it. So this guy had to be a solution to this guy, all right, to the differential equation. So take the derivative, okay, dy dx equals m. What is dy dx? Hey, they gave it to us, 2x minus y. Well, I want to combine like terms, so I substitute the y as well. There it is, do the math, factor, and we got it, okay. Let's go ahead and see if we can do one more, okay. And this is from 2016. And sorry if it's kind of hard to see, but it says consider the differential equation equals y squared over x minus 1. If you want to go ahead and pause the video and then try it on your own, go for it. If not, let's work together. It says on the axis, it says sketch the slope field for the 6 points indicated. I'm going to do this in red so you guys can see it a little bit better. And go ahead and go one by one. So 0, 0. So when x is 0, okay, and y is 0. So x is 0, that would be 0 squared. 0 minus 1 is negative 1. So you get 0 over negative 1. That means horizontal tangent. Okay. What about 0, 1? When x is 0, y is 1. So we get, just go ahead and do it. So x is 0, y is 1. So 1 squared is 1. So we get negative 1. When x is 0, 2. When x is 0, okay. When x is 0, 0, sorry, just thought about something, guys. 0 minus 1, and then x is 0, y is 2, 2 squared is 4. That'd be negative 4. It's really steep down there. We got to go back to the other problem. I forgot to add something. And then let's see, let's do this one here. 2 comma 0 when x is 2. When x is 2. Okay, y is 0. So guess what? Horizontal tangent. When x is 2 comma 1. When x is 2. When x is 2, 2 minus 1. And then y is 1. 1 squared is 1. So that becomes 1/2. I'm sorry, 1 over 1 was 1. And then the last one, 2 comma 2. When x is 2, same thing, 2 minus 1. And then y is 2. 2 squared is 4. So then 4 divided by 2 is 2. A little bit more steep. Okay. And you can see some symmetry going on in there. All right. And that's it. But let me go back to here to one of these that I forgot. Yep, this one right here. Let me go back to this one, guys. Sorry, real quick. I didn't answer this question. Determine the concavity of all solutions curves to the given differential equation in quadrant 2. And remember what we said, the second derivative, what does that give me? Concavity, right? So this is my equation right there. All right. So this is my concavity. Okay. Now let's take a look at the second quadrant. Okay. And what you can do is you can start putting, points here. But the second quadrant here, x is negative and y is positive. Okay. And let's go 1, 2, 3, 1, 2, 3. When x is negative 1, you get positive 2 plus something. So it ends up positive. If x is negative 2, positive 1, still positive. So if you notice, x is negative, y is positive. This whole thing here, it's always going to be positive. Okay? The second derivative in quadrant 2, it's always going to be positive. Okay? If you pick any value here, if you think about it, if you plug in any negative here, and then the positives, the y's, you're always positive, it's always going to be positive. Well, remember, what does the second derivative tell you? Concavity. And what happens when the second derivative is positive? It's concave up. Okay? It's concave up. So this guy is positive in the second quadrant because the second derivative is what? Positive. Okay? And that's it. I'm sorry, I forgot to add that in. Now let's go ahead and finish this guy right here. And it says we drew the differential, we sketched the slope field. So now let's go ahead and do letter B. Let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write the equation of the line tangent. You see that? Okay. To the graph at x equals 2, and then we got to approximate f of 2.1. All right. So as soon as I see write the equation, I go to y minus y1 equals m times x minus x1. Boom. Because that gives me a starting point. Plug in your initial condition. What is that? 2, 3. Okay. X is 2, y is 3. Boom. That's x minus 2. All I got to do is figure out my m. Okay. So if you did the slope field, I think they would have gave you 2 points for that. Oh, I don't have that one. All right. So let's go ahead and find the slope. The slope would be what? All you got to do is plug it in. Plug it in over here. Okay, so at 2, 3, when x is 2, so let's go ahead, dy dx, okay? So x is 2, y is 3, okay? And that would end up giving me 9. Boom, you're done. Don't do anything else to it, just leave it like that, okay? Now what do I have to do? Go ahead and figure out 2.1. So when x is 2.1, so y minus 3 equals 9 times 2.1 minus 2. Now, you're going to be able to use a calculator, so, hey, use it. If you're really scared you're going to make a mistake, just use it. Okay, 2.1 minus 2 is 0.1. And so you should end up with y equals 3.9. Okay, and there it is. Part B. Last one, part C. It says find the particular solution to the given differential equation with the initial condition f of 2 equals 3. So look at this. Find the what? Particular solution using this point. Boom. Okay. So I'm going to have to go ahead and separate this guy. Okay. So let's go ahead and do part C. So we have dy dx. And guys, try to be as neat as possible. I know you're working kind of fast and, you know, it's time consuming, but just be neat because they want to give you the points, but you know, as a human being, we're trying to find those points. If you're all over the place, it's going to be hard. How are we going to give you the points? How are we going to justify it? Okay, so and then dx is over here and then x minus 1. All right, so now what do? I do my integral. Integrate this guy. You want to go ahead and bring it to the top. Y to the negative 2 dy. Okay. What about this guy? Hopefully this guy is familiar to you guys. This guy is the same thing as, this is your ln dx over x. That's your ln of the absolute value of x. Okay, plus some constant c, of course. Now remember, this year in 2020, they're going to give you notes. So if, hey, your derivatives, have them in front of you if you need them. You should have them memorized to make your life easier, but hey, if you can't, just have them there with you. So this guy, okay, if I cover up like this, it's the same thing, ln. So we're going to have ln of the absolute value of x minus 1. Okay, now you can go ahead and do u substitution as well and do it if you need it, but hopefully you've done these enough that you can tell, because the u inside is just going to give you a 1. Okay. And then that's okay. All right. So now let's go ahead and continue here. Add 1, so y, negative 2 plus 1 is negative 1, divided by negative 1, okay? Normally we would do a plus c, right? But then because we have this one, we'll take it across and we'll have just one big constant. And so we don't need both of them. But let's just go ahead and leave it like that. So let's rewrite it here. And I think I'm going to go, let's see here. So I'm going to have negative 1. I'm just going to do the reciprocal because I don't like that negative exponent. And then this c is going to go to the other side. So I'm just going to have ln of the absolute value of x minus 1 plus c. All right, now that I'm here, what do? Well, I got to find that constant. So try to find that constant as soon as possible. That way we can just get it out of the way. So the initial condition is 2, 3. So when x is 2, y is 3. So ln of 2 minus 1 plus c. And then you get ln of absolute value of 1. Well, the absolute value of 1 is 0. So that means your c ends up being negative 1/3. And that helps you out a lot. Okay, it makes your life a lot easier. So we're going to go back. We're going to go back to here. Okay, so we're going to have negative 1 over y is equal to ln of the absolute value of x minus 1 minus 1/3. Okay, now remember, I got to solve for y. So what I'm going to do first is I'm going to multiply everything by negative 1 or divide by negative 1. So we're going to have 1 over y is equal to negative ln of the absolute value of x minus 1 plus 1/3. Now the trick here, guys, is just to do the reciprocal. Flip this guy, you're going to have to flip this whole thing over here. So that's going to give you y is equal to 1 over negative ln of the absolute value of x minus 1 plus 1/3. And just leave it like that because that's perfectly acceptable and I'll give you all the points. All right, guys. So hopefully that makes some sense and hopefully you're starting to get the hang of it and the patterns for these. All right, guys. Hopefully that helps. See you guys next time.